I'm Manuel Klimek. I work at Google, and I want to make C++ more fun than Java. I work in the Munich office, where we're building up a team around C++ tooling and specific C++ refactorings. And you might ask, why is Google interested in that? Why do we care? At Google, we generally care about three things. The first one is performance, and we kind of obsess about performance. The second one is productivity. We really like to throw more cores at stuff. Unfortunately, we cannot throw more cores at developing code. And unfortunately, there's not an infinite amount of talented developers, so we kind of have a scarce resource there. So we actually need to make sure that our developers are productive. And the third one we care about is fun, and we are very serious about that. Don't ever take away our foosball tables, right? So when we look at what C++ gives us here, performance, of course, check, right? Productivity, it's a little more contentious, but like we really like having abstractions for developers to be productive, and C++ gives us really cheap abstractions that we can build upon. So yes, productivity kind of, if we care about performance, productivity is a check too, right? Fun, well, not so much, right? I really like working in C++, but I really don't like doing boring, tedious tasks. And you all might have been in one of those kinds of situations where you just coded up this really great feature for your favorite open source project, and you made sure that it works, you made sure it's well tested, you made sure it looks pretty, and then you send it out, and then you get a review comment like, well, yeah, all your methods are incorrectly capitalized, and you're like, oh, shit. I really don't want to fix that now, and you go and you start renaming some, and then you run the compiler, and things break, and you go and fix it, and it's like, no, nobody should have to do that, right? So, quick poll, how many of you have, who work in C++ obviously, have ever not done a cleanup or refactoring just because they thought it's not worth it because it's too much manual work, right? Yeah, so I think you will agree with me that C++ could be more fun. Now, I'm complaining a lot here. I'm German, so I complain a lot. But I also have a solution for you. And I think the solution is really tooling, right? And when I talk about tooling, what do I mean here, right? The first thing, I never want to have to deal with whitespace again. This is the 21st century, right? I'm paid for going around in the source file and pressing like space and backspace. That doesn't make sense at all, right? Don't bother me with that. The second thing is style violation, right? Every project, every company have their own style guide, and I don't really care whether the ampersand is to the variable or to the type. I just want something to take care of it for me, right? This is something, as a human, I don't see it, and I don't want to spend time on that. What else do I want, right? When I give something a bad variable, like a two-letter initialization, I want to just be able to go and like change that and not be stuck with it forever, right? And the last one is kind of my pony wish, right? I don't know how many of you have ever worked with an IDE in Java. I really like doing TDD, and I've worked enough in Java to be really fixed by that. You write some code, you write some test, and you don't even have created any code for the class under test yet. And the IDE tells you, well, this looks like you're using a class here. Do you want me to create the class? And you go, yes, and there's the code for the class. And then it goes like, well, it looks like you call a constructor here. Do you want me to create the constructor with the types that I have to use you're using here? And you go like, yes, and then you're in the constructor and you hack away. And it's just, I don't think it's a lot more productive, but it's a lot more fun, right? And that's kind of where I want us to be, right? That's, I think, where we can beat other languages we're competing with, right? Now, at Google, we have tried for the past like year, 1.5 years to work on tooling, and we've learned a few things, especially why a few things are really hard. The first thing is doing things cross-translation. It's not only hard because you have to figure out what is the same thing in different translation units. But also for when you do refactoring, you have to change stuff in different translation units all at once. We'll go more into that later, why that is hard, right? The second thing is workflow integrations. There is a myriad of editors around here. Like people love their favorite editor. They've created their own workflow around them. And you cannot force them to just use whatever you want them to use, just to give them some tools, right? The same for build systems. There are lots of build systems out there. Every company I know has their own little build system. And the problem is in C++, you cannot really do anything with a source file unless you know how it is built. So you need a really good build system integration. And as usual, we really obsess about performance, right? Speed. For interactive tools, speed is a really important factor, right? And when we know that for C++ files, we take for like about 2 seconds to parse them, for an interactive use case, that's just too slow, right? So those are the things we need to address, right? Now I'm going to talk about things where I think we want to be a year from now. And this is not like set into stone. This is a proposal that we basically have that we want to work with the community to make a reality. And we need your guys' input for that and feedback and help. But let me just step you through a few building blocks that I think we want to get into place and make a proposal on how we can get there, right? The first thing that we need is libraries. Libraries that make writing tools really easy. On top of that, we want to obviously build some simple tools, right? Command line tools and stuff like that. And then we need to, as a second step, integrate all of that into people's workflows. For that, we don't have the luxury to just say, everybody use this IDE. So the idea is to build some services that have similar capabilities as what an IDE a user usually works in has, right? And then on top of that, we want to integrate the user's editors. And if your editor is like cat on the command line, that should be fine too, right? Let's look in a little bit more detail in what we are doing here. The libraries is something we are actually already have done a lot of work where we are working on open sourcing it. The first one we have is running a tool over a bunch of code, right? That actually landed in mainline last week. The interesting question you might ask is, why have a third layer for tooling? So let's look at what different base tooling layers Clang currently provides, right? The first one is Clang plugins. Clang plugins, it's great when you want very tight integration with your compiler, with your build system, right? The example is you want to break the build when you have some project-specific patterns in your code that you think are really bad patterns, right? Chromium, for example, has a build bot that runs with some Clang plugins enabled that will break the build if you do stupid stuff. The problem is the Clang plugins are very tightly coupled to your build system, right? They trigger, like when you run Clang as part of your build systems, it triggers when your dependencies change. So it's not made for running over arbitrary files. It's made for running in very specific cases when the source code changes or when dependencies change. So the second level of tooling infrastructure that's already there is libclang. libclang is a stable C interface that's great when you want to integrate, for example, from other languages or from an IDE like Xcode, right? The interesting thing is that it has very high-level abstractions, right? It gives you things like cursors, it gives you things like cross-references, but when you have the core Clang thing for running a tool is a front-end action, and you have a front-end action, you would just want to run that front-end action over your code, right? libclang doesn't answer you that. It also punts on the build system integration. And that's why we have the third layer we've been working on. And that's exactly like from the abstraction level, it's somewhere between the Clang plugins and libclang, right? it gives you more flexibility than the Clang plugins, but it's also more closely to the Clang core and more powerful than libclang. Right? And the idea is here really, I just want to run some front-end action I have over a string. Or then again, for the cross-translation unit stuff, I want to run my front-end action in one process over this set of translation units. And I want to be able to do something very specific afterwards with what I collected there. We come to that in a moment when we look at the refactoring cases, right? So when I say it must be easy to run something over code, that is what I mean, right? It's you have a front-end action and you execute it over code and you get back whether it works. This is also great if you work in Clang. If you want to unit test AST regressions or something, this is something you can use to do that. So now we have infrastructure to run tools over code, but we also need to change things, right? We don't only want to run a front-end action, we want to actually change code that we found. And for that, we need a refactoring library. Now, Clang already has a rewriter, Clang already has a source manager, and the problem is all of this is coupled very closely again to a one translation unit thing. And we wanted to run over multiple translation units. We wanted to be able to, like when you have header files and you do a refactoring on a function that's inlined in a header file, for every translation unit where this header file is included, you will get the same code transformations you want to apply. So you need to deduplicate those edits. And in the end, then, after all translation units are through, you want to apply all of them in one go so that your program is always in a correct compilable state, right? Then once we have the refactoring and the tooling, we want to make writing refactoring tools easier. One of the problems with writing refactoring tools is finding what you want to change, right? And for that, we've written a library that's called AST Matchers. Chandler has actually given a talk at the last developer conference where he goes into a lot more details about this. So if you're interested, watch that talk. I will give you a very high-level, quick overview over what that does, right? Basically, what we have is a very short way to express things in a kind of functional, in-language DSL in C++. Right here in the example, you want to match calls to methods that have the name eat, right? And you, instead of writing a recursive AST visitor and then like matching on the call expression and then like getting stuff out of the call expression, dynamic casting it, looking whether dynamic cast produced something that's not null, getting the next step out, dynamic casting, right? That quickly becomes like 20, 30, 40, 50 lines of code. And with the matchers, you have a very nice, compact way and maintainable way to express those interesting parts of the AST you want to work with. Right, and this nicely fits into our tooling base in that the matchers produce a front-end action. And you can use those front-end actions for your Clang plugin, or you can use those front-end actions for your tooling, or in the unit test. And then you get a callback once an interesting part was matched. That's the base of libraries on which we can now start building tools. And like I said earlier, the first tool we want to build is Clang format, right? The cure to all white space. Now, the problem is that it's hard, right? Formatting a C++ project has multiple problems to it. The first thing is it needs to be configurable because everybody has their own coding style. And then the problem is that usually even if you have a coding style, you have some legacy code that looks very differently from your coding style. And usually you value the consistency more than you actually value sticking to the letter of your policy, whatever that is. So you need some contextual knowledge about how you change the layout, right? The problem is when I change a bunch of code over a code base, right? I will often refactor a method name or something, and then the length of that method slightly changes, and then the indent of the lines below it changes, right? But I don't want to reformat all the files that I changed. I want to reformat just the part around it. That's important. That's what I mean by boxable here, right? I need to say only from here to here I want to indent, and then the problem is if all of the file around it is indented slightly differently from the coding style, it would be really great if we could like more stick to how the code around it is layouted. I think that's a very hard problem, but I also think it's solvable. So this is, the Clang format tool will be not only a tool on itself to reformat your stuff, but as I said, it's also one of the basic building blocks of refactorings on their own, right? Without being able to reformat code, you basically get very little value out of refactorings because you have to go in afterwards and change all the white space. So all you take away is some interesting changes, and then you still have to do all the stupid, boring stuff that you never want to do again, right? Another tool we would like is a clan lint. Now, you might ask, a clan lint, why not do that as a Clang plugin, right? Because it's something that basically warns you about bad code patterns. The interesting stuff is when you go and make that interactive, right? You don't only present the user with this code is bad, you also tell the user, like, oh, look, you could have written it this way, right? Or you could have written it that way. And give them the option to say, no, I know what I'm doing here, or say like, oh, that's interesting, just apply that for me, please. Right? And then going into the group of real refactorings, right, with the rename being kind of the mother of all refactorings that we have, we want to basically go through. We have Eclipse has a bunch of refactorings, and it knows how often they are used. So we can basically go in there for the Java people, see what refactorings are they using, and go the list top down and say, okay, let's implement those, right? Rename is obviously the first one. The interesting thing is we have to get them fast and correct, right? For correct, we have Clang. For fast, we'll look at that in a moment, and we need to be able to integrate them into the user's workflows. Right? It doesn't make sense to only have them in some IDE. We need them for the command line for your editors. So with that, let's look at the workflow integration, right? When we say IDE services, let's get a little more concrete here. The idea is to have a little daemon with basically a little wrapper around a Clang library running next to your code. And that's pretty much the same as running an IDE. It has context about your code. Like, it knows what you're editing. It stores cached information about the state the code is in. So it knows about your build system, how to integrate with your build system. Right? Many refactorings will probably touch your build system, and it is built with an RPC interface. So that you can integrate it from completely different other tools, right? And that will give us the speed, right? Because when you only have command line tools, you have to reparse the stuff all the time. You have to save dirty buffers and all that. And that's just too slow. So you want to keep information in memory, right? And you then want to be able to run arbitrary tools on that code, like with the tooling library we've just seen. And then, on top of that, we want editor integrations. Right? As I said, we don't want any developer left behind. We will not start a flame war on Emacs versus VI. I will perhaps grumble about VI a little bit in a moment. we also don't exclude Eclipse people, right? If they want to integrate with our services, fine, just write the integration and you're done. And obviously, we also always want to be able to get everything from a command line. Right, the idea is wherever you are, you have the equivalent of an IDE for C++ at your fingertips, right? And that is basically the high-level plan of where we want to go, right? We have been working on some of that, so let's look at where we are. The libraries are in progress, right? We're in the process of open sourcing them. The tools, we have built some tools, for example, the review email I had from earlier, right? That was one of the reviews I got for one of the patches I sent out around the tooling. And I thought, hey, a nail, I have a hammer. And I went and actually wrote a little tool that renames all methods if they are wrongly capitalized. But those are all early spikes that are basically can be developed into more like LLVM fixed style things. We also have with Clang, we are in a state where we haven't written any code yet. We have some ideas of, well, Chandler mainly has some ideas of what it should be. But it's getting more and more urgent for us, so expect to see some movement there very soon. And for the editor integration, well, yeah, that's a bit of a problem. Last week, I've actually played with integrating Clang check into VI, and I've cursed a lot. VI is not really made to be like integrated with different tools to run over stuff. It, yeah, cost me some nerve. So we need some experts here who can help with that, which brings me to what's next, right? We really need the community to help here. Code reviews, getting feedback on what your needs are, right? This is for C++ developers. So where you guys who are developing C++ are the customers. So chime in, say what you need from us, and we might even listen. With that, thank you.